We are looking at enhancing the number hunt project from the YByte Python curriculum available at www.ybyte.in. Now, number hunt is this pretty interesting game where we get the computer to pick up a number and then we as a player must guess the chosen number. Let's say we want to limit the number of attempts that the user must make to guess this number. In fact, this itself can be quite easily incorporated in the code as we just see in a moment. But really, this gives rise to very, very interesting questions the moment we start thinking on these lines. So that's what this video is all about. How do we limit this number? And then the question of how much should be this limit? And this, in fact, is quite an interesting question as we'll see now. So let's just get back to our code. I've gone to the basic class game that we have done previously. My computer picks up a number between 0, say 1 and 100 and tells me, and I have to guess it now. And it keeps increasing the attempts that I'm doing to guess this. Now, like I said, if I want to limit the number of attempts, well, it's quite simple. All I can do is that once the guess is done, I can just ask I can just put a, let's say, a comment over here, put a statement over here saying, say, if, let's say, attempts, attempts is greater than, say, max attempts, which means that, I kind of maybe, finish my quota. So I just put, let's say, print you have exhaust or you've finished all your attempts. Let's say finished all the attempts. Let's say all the attempts. And remember, we want this code to get over, which means that we want the while loop to get over, and hence I'm going to set the done to true over here, right? So just like the previous one, I just go and say done equals to, let's say, true. So with this, will make sure that beyond this attempts, I don't get to guess again. Now, of course, I must set the max attempts as a variable here, right? So right now, let's say I set max attempts to say, let's say 5. Now, so if I do this, so when I run this code now, it tells me, well, look, I have picked up a number between 1 and 100. Can you guess? So let's try. Let's say I try 1. It says larger than that, I say 23. Smaller than that, I try say 12. Larger than that, I try say 13. Smaller than that, larger than that, I try say maybe 20. Smaller than that, I try to say 16. And now it tells me, well, my number is larger than that, but I'm sorry, you've finished all your attempts, and that's it. You could not kind of guess this number. So quite simple to implement. All I really did was to have another condition here and, just basically say that, okay, look, done becomes true at the end of this, and hence the loop gets over. But like I said, a much bigger question comes up is how exactly should I set up this limit? So let's, think about this. What should be the maximum number of attempts that I should allow? But then this depends, right? It really depends on how large the search space is. So for example, if my, computer is picking up a number between say 1 and 100 versus say 1 and 20,000, then possibly I'll give more attempts to say 1 and 20,000. Also, the number of steps taken depends on the algorithm chosen for guessing. So let's say in my mind, I'm running an algorithm. Perhaps let's take some examples to make this all a bit more clear. Let's say we have to guess a number between 1 and 100. In that case, the chosen number is really 1 out of 100 possibilities. It is really, really not fair for me to say, okay, you must guess it once or say 2 or 3 times. Sometimes you can get lucky, but not always. So that's not a fair limit to put. I put 5 just now arbitrarily, but really that's also not a very fair limit to put. In fact, we know that it also depends on the algorithm. So let's say I choose a linear algorithm with step size of 1 in mind, which means I start guessing 1, 2, 3, 4, 5, and so on and so forth. And the number chosen is m. I'm going to need m attempts to guess it. So if my number is, let's say, 51, I need 51 attempts to guess it. It could even take 100 steps. But obviously, this is very, very inefficient. So we wouldn't want to give such a loose limit there. On the other hand, if I took, let's say, larger steps, I might, because in the beginning I take large steps and I keep reducing, I might take as many as 19 steps to, get the right answer. So it really depends on so many factors, how large the search size, how large is, let's say, what's the step you're taking. And in fact, it's a very good exercise for you to think about, maybe you can pause here and just think about, okay, given a particular algorithm, given, let's say, the number, how many steps will it take me to get there? And you'll realize that there's a large variation. Some numbers you'll get very quickly, some numbers you'll get with a lot many steps. So then still the question comes, how do I decide what is the just nice number for the number of steps that I should allow? One of the approach that I can ask, then one question that I can ask is that, okay, look, let me just think of an efficient algorithm here. What is the maximum number of steps that an efficient algorithm would take, right? And then I can say, okay, look, I have a benchmark. probably I can give my user, let's say, one or two more steps in that, because that is a reasonable benchmark. In fact, in this case, the efficient algorithm is binary search. We know that with binary search, we reduce the search space by half in every step, which means that, for example, if n was 100, so 1 to 100, search space becomes, let's say, 50 in one step, because I eliminate 50 choices, 25, 12. Now, because this, 25 is not divisible by 2, so that's not exactly half, but that's fine, get the idea. 12 in 3 steps, 6 in 4 steps, 3 in 5 steps, 2 in 6 steps, and 1 in 7 steps. Now, what this means is that no matter what number has been chosen, if I, as a guessing party, follows binary search, I will be able to get it in exactly, or say at most, 7 steps, no matter what the number is. And that is quite amazing. In fact, if you think about it, if n is a power of 2, now what does that mean? That means that I get numbers like 2, 4, 8, 6, which are basically numbers that I obtain by multiplying 2 many, many times. For example, take 4 is 2 times 2, 128 is 2 times 2 times 2 until 7 times, 1024 is 2 multiplied by itself, say 10 times. Now, it is quite easy to understand from the previous argument, because at every step, the search space goes down by half. So if I had the number between 1 and 128, at most 7 steps is all I need, provided I run binary search in my approach of guessing it. Likewise, if I had 1024, 1024 was the upper limit, so 1024, I will need at most 10 steps to get this, because again, at every step, the search space is becoming half. Now, this is actually quite remarkable. Notice I've gone from almost 10 times here. In fact, I've gone like 8 times bigger, but my number of search steps only increased 3. So 7 steps to 3. And this is pretty interesting. In fact, the general rule here is that, we will need, what is called logarithmic log to the base 2 of the n if the numbers are between 1 and n, provided we do binary search. Now, this may be a little bit advanced. We'll show you, how to do all this in Python, but this may be a little bit advanced for you right now, but take it as a formula. Try to sort of apply this, and we will see how to do it. Try to get a sense for it, because really what's going on is that we are reducing the step size into step size into half at every step. And this gives us a phenomenal benchmark. We can say, okay, look, if you did the most efficient algorithm by research, you will need, say, maybe n steps. I will give you probably 2 steps more than that, right? Because you are guessing, and that's something like that, right? So that gives us a pretty good benchmark to go about it. Let's now see all this in code, because this comes alive when we do this in reality, and the implications of this become more clear when we do this. Yeah. So first thing I'm going to do is that I'm going to say, okay, let me say, instead of putting a max, let's say fixing the number to 100, I'm going to set up, say, some variable called max num, and I'm going to say, okay, pick a number between 0, let's say 1, and say max num. Now, having done this, I want to tell my user that, look, my numbers come from, let's say, between 1 and say max num, and I ask my user to, let's say, guess this, right? So again, I put a print over here, so this looks pretty cool. Between max num, I'll want to put a comma. Sorry, what did I do? I want to put a comma over here, and really this is all I need to do. Let's see how this looks. Okay, so let the max returns be 5 right now. That's okay. So I say, okay, look, I picked up a number between 1 and 100. Can you guess it? Now notice here, I have an extra space over here, so that's not looking very nice. I'm also getting an extra space after 100. Well, I can fix that by putting a _b over here. Remember, _b is a backspace. The space is coming because, I'm not specifying any step here, so there's a single space created. But I can, that's looking a bit weird, so I can fix that, right? So if I do this now, let's say, so now it reads perfectly nicely, 1 and 100. The good thing now is that I can change range by just changing the max num, right? So if I, let's say, made 1000, then my computer is really picking up a number between 1 and 1000, and this makes it easy. Yeah. So now I want to compute the most efficient algorithm, number of steps it will take. So for that purpose, I'm going to have to import a library called the math. So math basically allows us to do mathematical functions. Now what I will do is I will use a bunch of functions here. Like I said, the formula is a little bit advanced, but let's see this in action to make it put more clear. So I just say, for example, let's say, max, in fact, we can do it right here. So max attempts is, let's say, math.ceil. So these are functions from the math library, and I will go and say math.log2 of, let's say, max num. Now what does this do, right? Let's just try to understand this. Let's say I make my max num to be, say, 128. Now, when I run this, right? So let's say, let me just control C this. Now, max num is say 128. When I do log 2 of say max num, that is logarithmic to the base 2. Okay, so I had to do math dot log 2 of max num, that is 7.0. Well, that's because 2 multiplied by itself 7 times is, so 2 times 2 times 2 times 2 times 2, so that's 5 times 6 times 7 is equal to 128. So that's what it means. I mean, if you know exponential logarithms, you understand this immediately, but this is basically what it means, that if I multiply 2 7 times to itself, I'm going to get a max num, that number 128. Now what I'm saying is that, look, you need to do at least that many steps. What happens when the log is, let's say, when I'm doing, let's say, log of log to 128 is what was 7, but if I had, let's say, 150, then it becomes something like 7.2. So I do a seal here to say, okay, let me go to the next integer. So I say math dot seal to, let's say, go to next integer, and that gives me an 8. So I'm going to say, okay, look, the max attempt is given by math.seal math.log2 max num. Now this, I mean, this is, I would say this is rather competitive because this is expecting me to now do binary search. Let's see how this works out. So, if I did that, so basically it says guess the number 100, 128. I'm going to guess 64 to start with. It says smaller than that, I'll try 32. Smaller than that, I try 16. Notice I'm just going in the middle of the range that I have. Smaller than that, I try 8. Smaller than that, I try 4. Smaller than that, I try 2. And that happens to be correct. In 6 attempts, I got it. Right? Remember, I had a large target, but I managed to do it because I did binary search. Let's up the ante here, right? Let's say I tried not just 1000, but I tried 1024. Now, my claim is that in 10 attempts, I should be able to get this, provided I do binary search in this, in the algorithm here, right? So I say, okay, guess the number. I'll try the middle of the range, 512. Smaller than that, I try the middle again, say 256. Larger than that, I try between these two. So that is going to be, 256 plus 128. That is 3, so 384. Okay, so I try 384. Smaller than that, now I need to, so smaller than that, I'm going to go between 256 and 384. So that is going to be 320. Smaller than that, I'm going to go between this and 256. I'm going to try 288. Larger than that, so basically I'm between 288 and 320. Notice my range has come down significantly. It says 32 numbers. So I'm going to try 288 plus 16. That is 304. Smaller than that, so I go, let's say, basically 28, so 304. So I'll try to do 296. Smaller than that, now I'm really converging in here. It's a 292. Smaller than that, so it is basically 289, 290, 291. So I'll try 290. That happens to be my number. I got this in just 9 attempts, and that is the power of binary search. In fact, I had a very, very ambitious limit set up here. Beyond that, it won't have allowed me, and hence I still managed to do it, and that is quite amazing. In fact, you can show that, as I said, this logarithmic too. So if I look at, let's say, 2 to the power of 15, which is something like, say 32,000 something, even though this is such a large number, I will still get it in 15 attempts, and that is so powerful. Now, just, like I said earlier, that, you don't have to be so strict on your player that he must do binary search. Probably I can give him a little bit of a leeway. I say, okay, look, maybe you can get 2 more attempts, and then you can be a little bit more relaxed. You don't have to think so hard while solving this. Now, clearly, you can put such limits on the time when the computer also guesses it, but that becomes a little, different, because we are choosing a particular algorithm beforehand and then going about guessing. So, accordingly, you can set the limits if you want to, but it's more reasonable, more intuitive, let's say, when I get the player to be putting these constraints. I hope you found this useful. In general, if you think this way of learning helps you, do look at our website, because we have many, many, many such projects for you that you can learn from. Take care. Thank you so much. Enjoy programming.